Hi, in this lesson we're going to go ahead to the problem solving exercise. We'll do these extension problems on page 34 and page 35. So number one, when 4 times a number is increased by 15, the result is 63. Find the number. Okay, first up we need to make this sentence, so we go slow. When 4 times a number, so there's our unknown, 4 times that is increased by 15. So we're going to be increasing it by adding to it and adding 15 to it. The result equals 63. Now we have an algebraic equation that we can actually solve. This is a two-step equation. We're going to have to isolate the 4n before we can get to the n. So we're going to take away the 15 from both sides so that we can have 4n on one side, and 63 minus 15 is 48. And now we can isolate our variable. So we are multiplying 4 times n, so we're going to divide, and we're going to do that to the other side. Canceling 4 divided by 4, leaving us with n is equal to 48 divided by 4, which is 12. So we've now found our number. So those ones are all good, but I really like the next kind of question, and that's what the focus is for most of these. And the first one, if you don't have strategies, these can really make your head spin. So we're going to look at the strategies that we use in order to create the sentences we need to solve. So we have Mary. She ran twice as far as Tom. They ran a total distance of 12 kilometers. How far did each person run? So when you have a problem like this, the key thing you need to find is the variable is for the person you know nothing about. So who do we know nothing about? So I'm going to write that on the side. Mary ran twice as far as Tom. So we know something about Mary. We know Mary ran twice as far as Tom. What we don't know is anything about Tom. So when we determine who we know nothing about, that person becomes our variable. So Tom, I'm going to assign as the letter T. And I'm going to write this on the side, and this is a good strategy as well. So Tom is T, and Mary, now we can say, what do we know about Mary? We know that Mary ran twice as far as Tom. Twice as means double, means 2 times. So Mary is 2T. She's 2 times Tom. They ran a total distance of 12 kilometers. So this means together they ran 12 kilometers. So let's add them. Mary is 2T. Now this is a lot of T's. This is a plus sign. Plus Tom, and you could use capital letters too. You don't have to use small t's. And you could use X instead, whatever you like. Mary plus Tom is equal to 12. Now we can solve, because what we have here are like terms. 2t plus 1t is equal to 3t. I'm combining my like terms. 3t is equal to 12. And now I can isolate t. I can divide by 3 and divide by 3, leaving me with t is equal to 12 divided by 3, which is 4. T represents Tom. Tom ran 4 kilometers. How about Mary? Mary is 2t, so Mary is 2 times 4, which is 8 kilometers. And that totally makes sense. Mary ran double or twice as far. 8 is double of 4, and together 4 plus 8 is 12. So Tom ran 4 kilometers, Mary ran 8 kilometers. So let's continue this strategy. Who or what do we know nothing about? In a cross-country ski race, Jack went 5 kilometers farther than Larry. They traveled a total of 81 kilometers. How far did each boy ski? Okay, we have 2 people, Jack and Larry. Who do we know nothing about? Jack went 5 kilometers farther than Larry. So we know something about Jack. So Larry is our unknown. So let's assign this with an L. So Larry is L, and Jack is 5 kilometers farther. So that means he's more than Larry. How much more? He's 5 more. So Jack is Larry plus 5. They traveled a total of 81 kilometers. So together, if we put them both together, we're going to get to 81. So let's do that. Jack is L plus 5, and Larry is L. And together, they make 81. So I'm going to use a darker plus sign to show that this is Jack plus Larry. Well, now I have a situation where I can combine like terms. I have L here and L here. So I have 2 of them. So I have 2L plus 5 is equal to 81. Now, I don't know about you, but I feel a bit weird using a capital L. I really prefer to use a small l for a variable, so you can do what you like. You could also use x. But we're going to solve regardless. So 2L plus 5 is equal to 81. So now I can get rid of the 5 so that I can isolate the 2L. So I'm going to subtract the 5 from both sides, canceling, leaving me with 2L is equal to 76. Because I'm multiplying 2 times L, I'm going to divide by 2 on both sides. And that's going to leave me with L is equal to 38. Let's go back to the information we wrote over on the left-hand side. What is L? Well, L is Larry. Larry went 38 kilometers. And Jack went Larry plus 5. So he went 38 plus 5, which is 43. And if we want to check, and that's kilometers as well, if we want to check, we can add them together. Jack was 43, Larry was 38. 43 plus 38 is equal to 81 kilometers. We know that we've solved correctly. Number 4, a play was attended by 330 people. There were twice as many women as men and 10 more children than men. How many children attended? Okay, we need to figure out who do we know nothing about. There were twice as many women as men, so we know something about the women, and 10 more children than men. So we know something about those children, but what we don't know is the men, and the men then become our unknown. And I'm going to use M to represent men. So here we go. So here's the men. They are M. Now the others are relative to them. Let's figure out the women. There were twice as many women as men. Twice as many means 2 times. The women are 2 times the men, 2M. And 10 more children than men. The children are the men plus 10. 10 more children than men. Now that we have everything we need, we can figure this out. So it says here how many children attended. So we have to put together the men, the women, and the children to equal the total, which is 330. And then what we can do is solve for the men, and then from there we can figure out the kids. Until we get the men, we're not going to be able to solve for women or children. So let's set this up. So the men, and I'm going to change my colors just to show. Some people use brackets. I prefer not to. The men plus the women plus the children equals the total number of people, which is 330. You can use brackets to show yourself men, women, children, but I find brackets can just get a little bit confusing. What I do now is I combine my like terms. Remember that this is like a 1 coefficient, and this is like a 1 coefficient. So let's put all of our m's together. We have 1m plus 2m, that makes 3m, plus another m makes 4m. Now we have 4m plus 10 is equal to 330. We can subtract 10 from both sides, canceling, isolating the 4m. It's equal to 330 minus 10, which is 320. Divide by 4 on both sides to isolate m. M is equal to 80. Now the question asks about children. So we don't have to even substitute for women. What we're going to do is take that 80 and substitute for the men plus 10. So the children is 90. So we have 90 children attending. We'll have 80 men, 90 children, and the women will be 160, and together they'll equal 330. Question number 5. Jan can lift 10 kilos less than Tanya. Mary can lift 3 times as many kilograms as Tanya. Together they lift 165 kilograms. How many kilograms can Jan lift? So we need to figure out our unknown. Who do we know nothing about? It's Tanya. We know something about Jan. We know something about Mary. Who we don't know is Tanya. So Tanya, here I'm going to assign her as T. Mary, 3 times as many kilograms as Tanya. 3 times. She's going to be 3T. Jan, 10 kilos less than Tanya. She's going to be Tanya minus 10. We're going to set this up now. Together they can lift 165 kilograms. So Tanya plus Mary plus Jan equals 165. Let's combine our like terms. T plus 3t plus t equals 4t minus 10. Very similar to the question above. This time equals 165. This time we're subtracting 10, so we need to add 10 to both sides of the equation. 4t is equal to 175. I'm bad. 5t. Goodness, that's a 5t. Equals 175. And from here, you're going to solve for t, and then you can solve for Jan. So we divide by 5, divide by 5. Tanya is equal to 35 kilograms.